Look up! That blazing orb in the sky is not just a source of light. It is a magnificent, fiery sphere that has fascinated humanity for millennia. It is a star, a giant ball of plasma constantly churning and burning with nuclear reactions at its core. We call it the Sun, a name that has been revered in cultures and mythologies around the world. It is the heart of our solar system, a cosmic engine driving everything around it. The Sun's gravitational pull keeps the planets, including Earth, in their orbits, creating a delicate balance that allows life to exist. Without the Sun, our planet would be a frozen, lifeless rock, devoid of the warmth and energy needed to sustain life. The Sun's gravity holds our solar system together, ensuring that planets, moons, and other celestial bodies remain in their paths. It dictates the orbits of planets, asteroids, and comets, orchestrating a cosmic dance that has been ongoing for billions of years. Its energy bathes us in warmth, providing the essential heat that makes our planet habitable. It provides the light that allows life to flourish, driving photosynthesis in plants, which in turn supports the entire food chain. The Sun is not just a star, it is our lifeblood, the very essence of our existence. From Earth, the Sun may seem small, but that's just an illusion of distance. In reality, it is a colossal entity, far larger than anything we can imagine. It is incredibly massive, containing over 99% of the solar system's total mass. This immense mass gives it the gravitational pull needed to hold the entire solar system together. To put that in perspective, you could fit over 1 million Earths inside the Sun. Its size and mass are truly staggering. The Sun's influence extends far beyond what we can see. Its energy reaches out into the farthest corners of the solar system, affecting everything in its path. Its magnetic field, the heliosphere, stretches billions of kilometers into space, creating a protective bubble that shields us from harmful cosmic rays. This heliosphere acts as a protective shield, deflecting dangerous cosmic radiation and ensuring that life on Earth can thrive. The Sun is a powerful force, shaping our corner of the cosmos. Its energy and gravitational pull influence not just our planet, but the entire solar system, making it a vital component of our existence. Solar storms and flares can have dramatic effects on Earth, creating beautiful auroras and sometimes disrupting our technology. Throughout history, the Sun has been a source of inspiration and wonder. Ancient civilizations built monuments and observatories to track its movements, and it has been worshipped as a deity in many cultures. Today, scientists continue to study the Sun, seeking to understand its mysteries and harness its energy for the benefit of humanity. Solar energy is a clean, renewable resource that has the potential to power our world sustainably. By harnessing the Sun's energy, we can reduce our dependence on fossil fuels and combat climate change. Future space missions aim to explore the Sun even further, unlocking new secrets and expanding our knowledge of this incredible star. As we go about our daily lives, it's easy to take the Sun for granted, but every ray of sunlight is a reminder of the incredible power and importance of our nearest star. So the next time you look up at the sky, take a moment to appreciate the Sun. It is more than just a light in the sky, it is the source of life, energy, and wonder. As the Sun sets and the day turns to night, remember that it will rise again, bringing with it the promise of a new day and the endless possibilities that come with it. Our Sun, a magnificent star, continues to shine, guiding us through the cosmos and illuminating our world with its brilliant light. The Sun might look like a smooth, fiery ball from afar, but it has a complex structure. When we delve deeper, we discover that the Sun is not just a simple, glowing sphere. It's like an onion, with layers upon layers of hot, dense plasma. Each layer has its own unique characteristics and functions. Unlike Earth, the Sun doesn't have a solid surface. Instead, it's a massive, seething ball of gas. It's a giant ball of gas, mostly hydrogen and helium. These two elements make up about 98% of the Sun's mass. At the Sun's core, temperatures reach a mind-boggling 15 million degrees Celsius. This is where the magic happens. This intense heat and pressure are the perfect conditions for nuclear fusion. Here, hydrogen atoms are forced together to form helium. Think of it as the Sun's power plant. This fusion process releases an enormous amount of energy. Here, hydrogen atoms fuse to form helium, releasing tremendous amounts of energy. This energy is what powers the Sun and provides light and heat to our solar system. Moving outward from the core, we encounter the radiative zone. This is a dense region where energy is transferred by radiation. Energy generated in the core slowly makes its way through this dense region. It can take thousands of years for energy to pass through the radiative zone. Photons, or particles of light, bounce around for thousands of years before reaching the next layer. This process is incredibly slow due to the density of the material. The convective zone is where the sun's energy finally breaks free. In this layer, energy is transported by convection. Here, hot plasma rises to the surface, cools and sinks back down, much like boiling water in a pot. This churning motion helps to transport energy to the sun's surface. This constant churning creates the sun's grainy appearance, visible through telescopes. These granules are the tops of convection cells. Finally, we reach the photosphere, the sun's visible surface. This is the layer that emits the light we see from Earth. This is the layer we see from Earth. The photosphere is about 500 kilometers thick and has a temperature of around 5,500 degrees Celsius. It's where sunspots, cooler regions caused by magnetic activity, appear. These spots can be larger than Earth and are temporary phenomena. The photosphere is just the beginning of the sun's atmosphere, which extends far out into space. Beyond the photosphere lies the chromosphere and the corona, the outermost layer. The corona is where solar flares and coronal mass ejections occur, sending charged particles into space. These events can have significant effects on space weather and can even impact Earth. When these charged particles interact with Earth's magnetic field, they create beautiful auroras, also known as the northern and southern lights. These natural light displays are a direct result of the sun's activity. So, the next time you look up at the sun, remember that it's not just a simple glowing ball in the sky. It's a dynamic, complex star with layers and processes that power our solar system and influence our planet in countless ways. The sun is a giant nuclear reactor in space. It constantly converts matter into energy through a process called nuclear fusion. Deep inside the sun's core, the pressure and temperature are unimaginable. They force hydrogen atoms to overcome their natural repulsion and fuse together. This fusion process creates a heavier element, helium. But here's the fascinating part. The helium atom has slightly less mass than the original hydrogen atoms. This tiny difference in mass is converted into a tremendous amount of energy according to Einstein's famous equation, E equals mc squared. This energy is released in the form of light and heat. Photons, or particles of light, carry this energy away from the core. They embark on a long, arduous journey through the sun's dense interior, eventually reaching the surface and escaping into space. Some of this energy reaches Earth, providing us with light and warmth. It powers our weather systems, drives plant photosynthesis, and sustains all life on our planet. The sun's nuclear fusion is not just a scientific marvel, it's the engine of life itself. In the vast expanse of space, Earth occupies a privileged position. Our planet is a unique oasis in the seemingly endless void, a place where life has not only emerged but thrived for billions of years. We orbit our star, the sun, at just the right distance for liquid water to exist on our planet's surface. This distance is crucial because liquid water is a fundamental requirement for all known forms of life. Without it, the complex chemistry that sustains life would be impossible. This region, often referred to as the Goldilocks zone, is neither too hot nor too cold. It's a narrow band where conditions are just right for life as we know it. The concept of the Goldilocks zone highlights the delicate balance required for a planet to support life. If Earth were any closer to the sun, like Venus, our oceans would boil away. Venus, with its thick atmosphere and scorching temperatures, serves as a stark reminder of what could happen if a planet is too close to its star. The intense heat would make our planet uninhabitable. The surface would become a barren, lifeless desert, unable to support the rich diversity of life we see today. On the other hand, if we were farther away like Mars, our planet would be a frozen wasteland. Mars, with its thin atmosphere and frigid temperatures, illustrates the other extreme of the habitable zone. Earth's position within the Goldilocks zone allows for a stable climate and the existence of liquid water, the essential ingredient for life. This stability has enabled life to evolve and adapt over millions of years, leading to the incredible biodiversity we see today. This delicate balance is a testament to the intricate workings of our solar system and the importance of our sun. The sun's energy drives weather patterns, ocean currents, and the growth of plants, which form the base of the food chain. The Goldilocks zone is not a fixed boundary, it shifts outward as the sun ages and becomes hotter. This gradual change will have profound implications for the future of our planet. As the sun continues to age, it will expand and increase in temperature, pushing the habitable zone further out into the solar system. This means that planets currently too cold for life might one day find themselves in the right conditions to support it. In the distant future, billions of years from now, Earth will eventually move out of this habitable zone. When this happens, our planet will no longer be able to support life as it does today. This distant future scenario reminds us of the transient nature of our current sweet spot. But for now, we are perfectly situated to enjoy the sun's life-giving energy. This energy sustains all life on Earth, from the smallest microorganisms to the largest mammals. It powers the photosynthesis in plants, which in turn provides oxygen and food for other life forms. Our position in the Goldilocks zone is a rare and precious gift, one that we must cherish and protect for future generations.